All right, are we ready for 7-1? Hey guys, those grades are not in SIS yet. I wanted to get them graded just in time to tell you. They'll be in hopefully early next week, okay? Okay guys, is this line paper any better or is this still bad? It's okay? I don't know, some people don't want it.
Yeah.
Then I asked one of my other classes, I'm like, okay, do you want blank paper, line paper, graph paper, and there was a so I'm like, oh, yeah.
Blank papers, I think, the best.
You like blank?
Yeah. That's the move. Blank. No, because then when you're doing certain lines on the line, and like, you know, when you do like fractions.
Okay, so it's true, but I don't like canceling it on instead of putting a
Maybe next time we'll make some with no lines, and some with lines.
But like, she instead of putting a 44, she put a 4, and I just saw myself. But then my semester grade was A minus, A minus, B minus. Like, so like, grades, Canada's grade, she passed. Mark says a 53, 9%. It's like, I would appreciate it. I was like, I think it was gave me the fifth grade sheet. She's had a file number. I was like, I can literally pull out the sheet of paper that has my grade on it. And she's like, did I write that?
Yeah, you did.
And I was like, yeah, since
I remember.
Okay, guys. Polynomial functions. This is what a polynomial function looks like. Let's do 3x to the 4th plus 2x cubed minus 7x squared plus 5x minus 1. That's the polynomial. And then here are some characteristics of your polynomial. The exponents are whole numbers. You know what whole numbers are. Okay, tell me some whole numbers.
3.
Good. 17, nice. What about like -1?
21.
No, not negatives, okay. What about 1.7? No, so it's 0, 1, 2, 3, etc. Okay? All right. The largest exponent is the degree. Okay, for class here, the 3 is the leading coefficient. And the -1 is the constant. graph is smooth and continuous. So last unit when we did like poles, asymptotes, jumps, if you have any of those discontinuities, it is not a polynomial. Okay. All right. Possible number of turning points. So we're talking about the graph, like when it changes from increasing to decreasing, that sort of thing. That's a turning point. That is always the degree minus 1. Or you might see it written as n minus 1. So if I give you f of x equals 2x cubed plus 4x minus 1. What's the possible number of turning points for that? Yes. You take the degree minus 1, so 2 possible turning points. All right, then we have the possible number of solutions for x-intercepts. That's always just the degree. And you'll hear us talk about solutions, zeros, x-intercepts. For the most part, they're interchangeable. Okay, there's a few instances that we'll talk about where details of that matter, but for right now, use them however you want. So if we go back to that example there with f of x, how many zeros or solutions could that have? Yeah, so you have 3 possible solutions. All right, let's talk about the x-intercept. And the y-intercept. If we're looking at an x-intercept, what's happening on our graph? What could you tell me about an x-intercept? What do you think? It goes through the x-axis, exactly. So what is your y value if you're on the x-axis? 0. Okay, so an x-intercept happens when y equals 0. You're going to write them as ordered pairs. So it's going to be something, comma, 0. And finding an x-intercept usually involves a little bit of work. Usually some factoring, setting things equal to 0, stuff like that. And you could have more than one. Okay. What about your y-intercept? If we're on the y-axis, what is happening? is 0. So this happens. When x equals 0. So it's going to be 0 comma something. It's always the same as the constant. So that's much easier to find. You just look, anything with an x, ignore. Whatever the constant is, that is your y-intercept. Do you think there could be more than one y-intercept? Right, then it wouldn't be a function. If you have 2 points on the y-axis, something's not going right with your x values there. Okay. Okay, so what do I want to tell you about these? All right, let's talk about multiplicity. This happens when the same factor occurs more than once. You can have even multiplicity and you can have odd multiplicity. Even is called a point of tangency. You probably talked about it last year as a bounce off the x-axis. Odd multiplicity is called a point of inflection. Let's look at an example here. If I had f of x equals x minus 1 cubed times x plus 2 times x plus 4 squared. Your solutions to this, or your x-intercepts, would be x equals 1, x equals -2, and x equals -4. You guys are okay with that? You're just setting the factors equal to 0, okay? But then let's talk about the multiplicity. So x minus 1, that's raised to the third power, right? Is that an even or an odd exponent? Okay, so at x equals 1, you would have a point of tangent. I'm sorry, a point of inflection. Because that one has odd multiplicity. I'll show you on a graph what it looks like.
Okay.
You know a cubed graph? That's what a point of inflection is.
Okay.
Like, because that kind of levels out and then goes up again. All right, now x minus 2. Yes, there is a 1 outside this parenthesis, but is a 1 happening more than once? No, so there's technically no multiplicity on this 0. So it's just crosses the x-axis, nothing fancy or special. And then this one, x plus 4 squared, what type of multiplicity is that? Even, because the exponent's even. So at that point on your graph, you would have a point of tangency, or a bounce. So what you're going to have to do with this is sketch a graph based on what you know about turning points, y-intercepts, multiplicity of the zeros. Okay? It's not as bad as it sounds, I promise. Questions so far on any of the terms or anything like that? Okay. Let's try. An example here. You are going to find a polynomial in factored form of degree 3 whose zeros are -3, 2, and 5. Alright, I'll walk you through this one. I'll let you write first. Okay, so anytime I'm asking you to write a polynomial or an equation, please start with f of x equals. Okay? The degree is 3, and I've given you 3 zeros, so that just means you're going to have 3 factors. All right? If -3 is one of the zeros, what would the factor be that created that zero? X plus 3. What about the 2? Minus 2, and then the 5. X minus 5. Okay, now the direction said in factored form. Is that in factored form? Yeah, it's like parentheses, parentheses, parentheses. Please read your directions, because if you take the time to multiply out all 3 of these, it's going to take you a while, and it's not what I'm actually asking you for. Okay, so you would waste time and lose points. That just, no one needs to do that, okay? So just read the directions. If I ask for it in standard form, that means multiply it out. Most of what I'm going to ask you for, though, is in factored form, okay? All right, questions on that one? Okay, we are going to try to start sketching some graphs.
So it's degree 3 because when you multiplied it out?
Yes. Yeah, good question. So degree 3, think about it. And anytime you're checking the degree, if it's in factored form, you don't have to actually multiply it out. What would x times x times x be? X to the 3rd. That's all you need to do to check the degree, is multiply the x's together. Okay? All right. Let's sketch a graph. We're going to do several of these, so I'm going to walk you through the first one. Let's do x cubed minus 2x squared. All right, you'll notice I'm not putting a bunch of tick marks on my graph. Okay, don't. Don't mark it all up yet. Okay, so our function here, f of x equals x cubed minus 2x squared. To graph it, it needs to be in factored form. So, can we factor this? What could I factor out? Okay, so f of x equals x squared, and then what's left in parentheses? X minus 2. We're okay with that step, right? I'm going to do this a step at a time. It's a Friday morning, guys. All right, so looking at the factored form, what are my zeros or my x-intercepts? Either way you want to say it. They happen when x equals what 2 things? 2 and 0. Good. 0 and 2. So on my graph, I'm going to put a dot where x equals 0, and then I'll just put 2 tick marks in, put a dot where x equals 2. All right, questions so far? Yep. That is your y-intercept. Yeah, your constant 0. So it crosses. Good. Yep, so we can think about that. So our y-intercept is 0, 0, right? Because your constant was 0, and you already graphed it at 0, 0. It's the only place it's going to cross the y-axis. Okay. To start the sketching, 2 things you have to think about. You've got to think about end behavior, and if you have multiplicity on any zeros. Do we have multiplicity on any of our zeros or x-intercepts here? Which one?
X equals 0.
Yeah, this one was an even, right? Okay, so you're finally going to see what it looks like when it bounces off the x-axis. And now, go back to your original here. X cubed. What do the ends of a graph look like if it's x cubed? As I go to the right, where does the graph go? Up, right? So draw up. You draw that. Okay, step 1. And then to the left, where does my graph go since it's cubed? Down. Okay, so I'm going to draw down. You're well on your way to your graph, okay? Okay. This one I know just has to cross the x-axis because there was no multiplicity. This being even means it's going to bounce off of the x-axis. So it touches the x-axis and then comes right back down, and then I can cross here. So that's what your final graph looks like. I'm never going to ask you what this point is, like what this minimum is. That's not what you need. I need ends. I need zeros. I need the y-intercept. Yeah, that's hard to find. Calculus, it becomes much easier to figure it out, but for what you're doing right now, no. That's also why don't put tick marks on your y-axis, because who knows, like maybe that's -3, maybe it's -17. I'm not wrong if I don't mark those tick marks, okay? So just don't. Questions on that first one? Okay, let's try another one. We're going to do a bunch. So same directions here. Let's do x plus 3 squared times x minus 4 cubed. So I want you to think about what is the degree. What are your x-intercepts with multiplicity? What's your y-intercept? You guys want to try this one? Make the sketch? Yes? So just to make sure you're off to a good start here, guys, what's the degree? No. This is a little trickier. So what would this x actually be? X to the x squared, and this one would be x cubed. So together that would be 5. Okay? Again, we'll practice lots of these. So the degree of this is 5. So how many x-intercepts does this one have? 0. Plot those if you're not sure what to do with the multiplicity of sum.
Wait, is the y-intercept not 0?
Well,
Is the y-intercept not 0?
the y-intercept is not 0. It's a
Oh,
rather
so it's
large
not
number.
Yeah. That's right.
Okay.
Because it's
Which again,
that.
don't put tick marks on your y-axis. Just stick the dot on there and label it. And even if it's
Okay, that makes
a very big number, that's okay. All right, you got some points. Good stuff. Think about what the ends would be doing. You can draw those in. So it's 5. Or your ends are
The y-intercept?
So it's really 3 squared times negative 4 cubed. So your y-intercept is, well, it's negative, but otherwise it's a very big number. I actually don't know, so I guess 64 times 9, right? Hold on, let's try one more.
Oh, I don't know how to double point.
Did you get like negative 576 for your y? Okay. Who wants to put in that many tick marks? Me. So guys, what I do on that, if I'm graphing it, like, all right, I'm putting a dot down there, and I would label it 0, negative 576. Okay? That's it. You've covered it on your y-axis, no tick marks, so you're not wrong. Okay, so with your y-intercept, x is 0, right? So if I put a 0 in for both of these x's, that leaves me with 3 squared times negative 4 cubed. 3 squared is 9, negative 4 cubed is negative 64. Multiply them, you get this lovely number. Okay? So I won't make all of them that big. That just happened. Okay? All right. Are you guys okay with those 3 dots? Okay, so next I would draw in your ends. Where are your ends going? Where does the right side go? Up. Where does the left side go? Okay, so I'm going to draw those. And that. Okay, it's getting closer. All right, now we got to deal with our multiplicity. So at -3, I have an odd multiplicity. I'm sorry, -3 is even. So I wrote the wrong thing. That one's even, this one's odd. That works. All right, so at -3, what is it going to do? Is it going to cross? Is it going to bounce? Is it going to be inflection? What do you think? It's going to bounce. So it's going to touch it and come right back down, which makes sense because the next point I have to go through is that y-intercept. Okay, then we're coming back up, and now we got to figure out what do we do because this one has odd multiplicity. You guys know what a cubed graph looks like? Okay, that has odd multiplicity, so that's the shape you should be trying to draw. So I'll see if I can. Trying is the key word there, yes. So we're coming up. Show me that there's something that it's not just a straight crossing through the x-axis, okay? It's not going to be perfect every time, but show me that something is happening. I've even had kids label it, like on their quiz or test, they draw it, and then they write inflection and draw a little arrow. So like I know you know that that's what's supposed to happen. Our drawing skills sometimes don't match up with what we know. So. Okay? So that's the end of that graph. Okay?
Just have to show that it's curving.
Yeah, that it's not like,
Not just one straight.
it just doesn't go that way.
Yeah,
That'd be for the first two. Okay? All right, go again. Questions over that one? Is it getting a little better? Okay. Some of you look okay, some of you just look like this whole week business is not okay.
Because I was like, I was trying to say.
All right, let's try -2 times x plus 1 cubed times x minus 2. So think about your degree. That's going to help you with your end behavior. X-intercepts, Y-intercept. Yes, I've stuck a -2 in front. Okay. So I'll give you a minute. Check in, see how your degree is going. You okay?
No, I was recording.
Oh, so we're just gonna go. That's a good one.
But she was trying to tell me something. Trying to write in Spanish. So long thing I was trying to say.
Have you guys seen Coco yet? Actually, really good. Yeah. No, it's out on DVD now. So. Okay, what is the degree?
4.
4, yes. We okay with that?
Sure. I'll take it.
You got 3 here, right? 3. And what's here even though we can't see it? 1. And 3 plus 1 is 4. So think about what your ends of your graph are doing now. It's an even degree and you've got that -2 in front. Okay? How many x-intercepts do we have? 2. Okay. Y-intercept is a little easier to find this time. I picked nicer numbers for you. Just a little. the y-intercept is manageable.
Yeah.
And guys, it's good to plot that y-intercept before you start actually graphing the line, because you'll kind of figure out if your end behavior is wrong or if you're doing a multiplicity wrong. You're not going to be able to go through that y-intercept without making up an extra x-intercept. So it's just a way to check to make sure you're doing it right. A little more time here, then we'll look at it.
Draw this little squiggle. I realized that I had the right graph. It was a positive graph.
Yeah, let's see. 1 cubed 1, negative 4. You could just take marks if you wanted to do that.
Yeah, I did.
I'm still just going to be like, there you go.
There is no way. It's easier to just do works. This is like, this. Alright.
Guys, do you have those 3 points? What are your ends doing on this one? Both go down, right? Did you say they're frowning? Yes. So I know I've got down and down. The only thing else I have to deal with then is the odd multiplicity. So what is happening at negative 1? Like squiggles, right? So you can't just go straight through. You've got to like make a little something. But that one should not be. That's terrible. All right. How do we do? Okay. Raise your hand if you got it right. It's okay if you didn't. I just want to know if we're okay. Those of you that didn't, I'll come check and see on your next one here. All right. So let's try one that's not already in factored form. It's actually easier to see the degree and the y-intercept when it's not factored, but harder to see the x-intercepts. Okay, so you just have a little bit of work to do. 2x cubed minus 7x squared minus 4x. So same thing. 3 x-intercept, y-intercept. Factoring will take you a minute, I realize. I guess I'm just handing back your homework packets from last time.
Yeah, that makes more sense.
How's your factoring going, guys?
Okay, there we go. What the heck here? Good stuff.
Once you've got a graph, make sure you're talking to someone around you, checking to see if you guys agree.
This is really worrying. It's just close. Whispering. It's so annoying. Stop whispering. It's annoying, he's just whispering. Okay, that was not.
All right, guys, your degree is 3, right? What's your y-intercept?
0.
0, 0, right? That's an easy one. Okay, you gotta factor this to find your x-intercept. I can take an x out, right? And then I'm left with 2x squared minus 7x minus 4. How'd you guys do with your factoring from there? Again, I do not care. Guess and check, draw some weird circle thing, factor by grouping, like I don't care what you do, just as long as you get to the right factors. What you guys come up with as your factors? Perfect. If this is really hard for you to factor, that's not the end of the world, but please come into some Warhawk time so that I can give you some extra practice on factoring.
Forgot to factor.
Okay, yes, factoring is key. It's that one thing that just never goes away in me. So if you're not great at factoring when there's a leading coefficient, again, not the end of the world, but something we got to work on. So come in and see me in Warhawk time if that's tricky for you. So I have 3 x-intercepts, right? Okay, I've got 0, 0. I've got -1/2. And I've got 4. Do any of them have multiplicity? No. Okay. So, plot my points. So -1/2. And there. These two are really close together. 4. All right, the degree was 3 and it was positive, so where are my ends going? Up, so this guy's down, this guy's up, and then it just crosses, crosses, crosses. That's it. Do we like it better when it's given to us in factor form? I know, the -1/2 and 0, I don't. Okay, let's do one more. Anybody questions on this one? Sorry, I don't mean to go through it too quickly. All right.
Sometimes the answer even needed.
Give me a couple more minutes, guys. Talk to each other.
Somebody's not going to negative 1, 2. I was like, you guys are slurring. There's, someone starts saying, there's another one, but I forget what it was. And I was like, I like looked at it. It was all,
Are we ready, guys?
you guys are so racist.
All right, guys. What's the degree? 5. Okay.
But calm down.
X-intercepts, I've got -4, 1, which has odd multiplicity, and -2. All right, Y-intercept. 0 what? Let's see.
8.
8, yes. All right, so let's plot these points. 0, 8. 4,
No, I'm kidding.
1,
-2.
All right, guys, where are your ends going on this one?
It's on you and it's the line.
Yeah, to the right. This time goes down, to the left goes up, because we've got that negative in front. Did everybody catch that? Okay. So this one goes down.
It's pretty well hidden.
This one goes up.
I usually.
It just crosses nicely, and then you've got your weird point of inflection over there. I don't know why, but coming from the left, I think the inflection is so much harder to draw. Like, there we go. A little better. Okay. How do we do on that one? Raise your hand if you got it. Okay, I'm not feeling you got that one, or are you just not telling me that you got it? You're just, it's too hard to raise your hand this morning. It's just too much. So guys, how do we feel about the sketching of the graphs? Like thumbs up? Oh, I want to go home and cry. Most of you are somewhere in here? Okay. No tears? All right. Let's stop there for now.